Hello students, in the last section and the last videos of kinematics, we have discussed about the motion in one dimension. Now here we can say a part of kinematics, this what we will discuss today, that is your projectile motion. That we will discuss about the projectile motion today. In this video, means the projectile motion is like the motion in two dimensions. We can say the motion in two dimensions. Two dimension means there are two parameters, two coordinates, x and y coordinates. Means the motion of the particle such that it has two coordinates that changes with respect to time. Two coordinates changes with respect to time. So that we will discuss in our projectile motion. So first concept is what is a projectile. So a projectile, you can say a body which is in flight through the atmosphere, a body which is in flight, a body which is in flight through the air medium, which is in flight through the air or atmosphere, or you can say that through the atmosphere under the influence of gravity, under the influence of gravity. It has only the influence is only the gravity, means the force of attraction of earth to a body, that is our gravity, force of gravity or simply gravity. And remember one thing, a body which is in flight through atmosphere, it is in the flight, means it is in the atmosphere under the influence of gravity, alone, without being alone. That is only the one force, that is the force due to earth, influence of gravity alone, and without being propelled by, and without being propelled by, means we are not giving anything. Propelled means we are not giving anything or fuel, propelled by any fuel. It's called projectile. It's called as a projectile. That is very, very important. This is called as a projectile. It's called a projectile. Clear? So a body is in flight. I throw a body with some initial velocity from the ground or from a top of a tower. I have given some velocity, initial velocity, and it is in the atmosphere. It goes to the atmosphere and it will go in the atmosphere. What happens we will discuss later, but flight through the atmosphere under the influence of gravity. Once initial velocity is given, now it is under the effect of gravity. No other forces are acting on that. If it is under the action of gravity, then your acceleration due to gravity comes into play. Because of the force, there is an acceleration. Because of the force due to earth, that gives an acceleration to the body, and that acceleration is your acceleration due to gravity. Means it is influenced by the acceleration due to gravity alone, without being propelled by any fuel. Means during its flight, we are not propelling or we are not giving anything or any fuel to that body, or any force is not applied there. That is called as a projectile. And the examples of projectile, you can say, suppose in the aeroplane a bomb is released. A bomb is released from the aeroplane. The aeroplane is in the atmosphere and it releases a bomb or a bag, a relief packet is dropped from the aeroplane. So that path and that body is called as a projectile. Right? Then another example, right? An arrow is released from the bow. If we release an arrow from the bow, right, then that arrow path is a projectile. The arrow is the motion of the arrow is a projectile motion, and that arrow is now called as a projectile. So here we can say that the body which is projected, that is obviously a point object. We know that the dimension is very negligible compared to its path traveled. Here we will consider that is a point object. Similarly, a stone thrown horizontally from the top of a building. You stand on the building and you throw a stone horizontally like that. I will throw a stone like this. Then that is also a projectile motion. So this is about the examples of projectile motion. Then the path followed by the projectile, the path followed by a projectile is called its trajectory. Here path of the projectile is called, path of the projectile means that body is called its trajectory. That path is called as a trajectory. We not use the term path, we can say that is a trajectory. The trajectory of the projectile means the path of the projectile. You will understand that the path of the projectile. And the motion is the projectile motion is a two-dimensional motion. The motion is a two-dimensional project. Okay. So now the most important thing is that when we consider the motion of a projectile, the assumptions, we use that some of the assumptions. What these assumptions are like that? There is no resistance of air because the body is in atmosphere. Air has some resistance, means air giving some damping force, oppositional force to the motion of the body. But the motion is only affected by the force of gravity. Means air resistance is neglected. So means there is no resistance due to the air. Next, the effect of the curvature of earth is negligible. The effect of curvature of earth, as you saw, the path of the surface of the earth is like curvature. So this effect of curvature is not considered in this projectile motion. This is not considered in the projectile motion. And the next one is the effect due to rotation of earth. The rotation of earth is also negligible. The earth is rotating, that rotation of earth is also negligible in this discussing in this projectile motion. And for all points of the trajectory, means the path of the projectile, the acceleration due to gravity, as I have already told, the acceleration due to gravity, that is generally we are considering this is g, the acceleration due to gravity is constant in magnitude and direction because it is only affected by this acceleration, this force of gravity. So that force of gravity gives you acceleration due to gravity. Force is applied, it gives you acceleration because F is equal to mass into acceleration. So these are the assumptions while discussing this projectile motion, right? So by these assumptions and what is a projectile, now we will go for the projectile motion. Now, there are two types of projectiles. One is called horizontal projectile. One is horizontal projectile. What that horizontal projectile? One is called horizontal projectile. What is this horizontal projectile? If a body is projected horizontally from a certain height, if it is projected horizontally from a certain height, then the body is called a horizontal projectile. Means there is a certain height, from this certain height we throw a body, right? So if you throw a body means the body will throw with some initial velocity. Suppose u is the initial velocity at this point and this is thrown horizontally, right? So now the body is projected and it will come to the ground like this. So this is the ground surface of earth and the body, and here we are not considering the curvature of earth because the earth is not like that, it is curvature. That curvature we are not assuming. So in this part, if you are giving some initial velocity u and it is thrown horizontally, then this type of is called as your horizontal projectile. This type of motion is called horizontal projectile. Then another is the oblique projectile. The number 2 is oblique projectile. What is this oblique projectile? The second oblique projectile is that if a body is projected at a certain angle with the horizontal, if a body is projected with a certain angle to the horizontal, suppose this is my horizontal and I have given certain velocity u with an angle theta with the horizontal, then if I take, this is a two-dimensional motion, so there must be x coordinate, I will consider this one and this will consider as y. So the surface of earth I have considered x coordinate, x axis, and this is the vertical y axis. So as the body is projected, so it is under the influence of two parameters x and y. When the body goes like this, the two parameters x and y changes, two coordinates changes. So that's why it is a two-dimensional motion. So in oblique motion, it is projected with some angle theta with the horizontal with some initial velocity. Then the body is called as an oblique motion. Okay. So these are the two types of motion. We will discuss one from horizontal projectile, one is from oblique projectile. That is in our syllabus. We will discuss one by one. Next, another thing is that there is very important parameter, very important thing, or we should consider that the principle of physical independence of motion. What is this principle of physical independence? Principle of physical independence of motion. What it means? Principle of physical independence of motion. As I have already told that the motion of a projectile is a two-dimensional motion. Clear? Right. So it can be discussed in two parts. One is horizontal motion, the other one is the vertical motion, because it is a two-dimensional motion. So means there must be a horizontal motion and there must be a vertical motion, right? Like, so in this concept we can say it should be discussed in two parts. One is horizontal motion, and the other one is the vertical motion. Means, take an example like this. Suppose there is a x and y, and a projectile is projected with some certain angle u, with a certain velocity u at an angle theta in this direction. So in this part, when the body goes like that, we will discuss how if this is the projectile like this, so this is the path or trajectory of the projectile. Suppose we will go for it. Why this trajectory is like this? So in this motion, the motion is what this physical independence of motion means. There are two motions, one is a horizontal motion and vertical motion at any instant. Suppose I consider here. So in this part, there must be a horizontal motion and there must be a vertical motion. Suppose I consider here, this is a horizontal motion and this is a vertical motion. Already you know that component form. So if this is the u with an angle theta, so u has a component along this direction, so obviously this is u cos theta and this is obviously u sin theta. So there are two components, one is horizontal component and the vertical component, and this horizontal component gives horizontal motion, the vertical component gives vertical motion. Okay, and these two motions take place independent of each other. These two motions are independent of each other. Means because of this u, it gives you u cos theta and u sin theta, and these two motions are independent of each other. That is the principle of physical independence of motion. So in the projectile motion, there are two components of the motion, horizontal and vertical, and these two motions are independent of each other. And most important, this remember, at any instant the velocity of a projectile has the horizontal component and vertical component, and these two are independent. And remember another thing, the horizontal component always remain constant. The horizontal component always remain constant. So let me show it is more clear about this thing. The horizontal motion, so suppose this is the projectile, this is x and y, and suppose it is projected with an velocity u and the trajectory is like this with an angle theta. So this is tangent to this one, this is the velocity, and the projectile goes like this. Okay, so we can show the at any point the velocity means we can show it like a tangent form. So this is the velocity at this point. So it has a horizontal component and it has a vertical component. Similarly here also at this point, suppose I consider this is the velocity, it is a horizontal component and this is a vertical component. So u means, suppose it is u cos theta horizontally and u sin theta vertically. So here also suppose it is another velocity like, so this is the horizontal and this is the vertical, and remember always this horizontal component is, or horizontal motion is always constant. So the velocity, the horizontal velocity, or you can say the horizontal component remains unchanged throughout the flight. Throughout the flight, this horizontal component at this point horizontal, here this is the horizontal, so here this is the horizontal. At every point the horizontal component is constant and the vertical component is continuously affected by the force of gravity because the body is thrown vertically up. So as the body is thrown vertically up, then the vertical motion is influenced by the, continuously affected by the force of gravity. Thus, while the horizontal motion is a uniform motion, the horizontal motion is a uniform motion and the vertical motion is a uniformly accelerated motion, means at every place the acceleration due to gravity remain constant. Already we have discussed in the assumption part. So g always constant and the motion is takes place near the surface, very close to the surface of earth to a certain height. In that we are considering this projectile motion. So this is very important. Again I am repeating the thing. During the projectile motion, its horizontal motion remain constant. So the acceleration due to this horizontal motion is 0 because the velocity always constant. U cos theta, u cos theta. So here also u cos theta, here also u cos theta. Suppose I will ask what is the change in velocity from this to this? Horizontal 0. So acceleration equal to rate of change of velocity. So no change in velocity, so the horizontal acceleration is 0. But it is influenced by the vertical because it goes up. So it goes up like this. So it goes up like this means it is under the effect of gravity. So always the acceleration, uniformly accelerated motion in vertical. Uniformly accelerated motion in vertical means in vertically the velocity changes. In vertically the velocity changes. The vertical motion or vertical velocity changes, and that is under the influence of the gravity. Under the influence of gravity. Okay. So with these assumptions and with this discussion, principle of physical independent motion, we discuss the oblique projectile or the projectile fired at an angle theta, with the horizontal. Now we will discuss that part. Let me erase this thing. We will go for the oblique motion. Okay, now come for the oblique projectile. So here in this oblique projectile, let us consider a projectile thrown with a velocity u at an angle theta with the horizontal. So let us consider a projectile. Let me show it here. A projectile, this is the x component and this is y component. A projectile is projected with a velocity u at an angle theta, and this, suppose the path, we will show that why this path is like that. So it is thrown with a velocity u at an angle theta with the horizontal. Clear? So with a velocity u at an angle theta with the horizontal, the velocity u can be resolved into two components. One is u cos theta and this one is your u sin theta. Two components, u cos theta and u sin theta. Okay, and obviously this is u cos theta and u sin theta. Suppose I show like that, then we can say how we will show this one. Suppose it is a form like this. So this is your u cos theta and this is your u sin theta. We can show that x distance u cos theta, motion along horizontal u cos theta, vertically u sin theta. Okay. So as we already know that is because of the motion, it is a two-dimensional motion. The velocity u has resolved into two components, u cos theta along x-axis, u sin theta along y-axis. The motion of the projectile can be supposed to be made of two motions, horizontal motion along x-axis and vertical motion along y-axis The horizontal motion of the projectile means this u cos theta. This horizontal motion of the projectile is uniform motion. Because why this is uniform motion? This u cos theta is uniform motion, means this u cos theta at any point, this u cos theta not changing. Suppose you come to this point also, this u cos theta is not changing, here also u cos theta, here also u cos theta, everywhere this u cos theta is not changing. It means that, why? Because the body is projected means it is only influenced by the gravity, that is the force of gravity, or simply you can say that gravity. So this gravity acts vertically downward, it pulls everybody towards its center. Earth pulls everybody. So suppose you consider this is the surface of Earth, pulls the, so the vertical motion is influenced by the gravity. The vertical motion is influenced by the gravity. Okay, and the horizontal component, so the acceleration, suppose it is in velocity u, then you can say that at any point the horizontal acceleration is 0, because there is no change in the horizontal motion, it is uniform. So the acceleration horizontal is 0 and vertical acceleration is equal to the acceleration due to gravity, that is your g. That is the part we have to remember. Okay, then next, now we will go for the trajectory of the motion, means it will follow this path or any other path. Like, so this path is like your parabolic path, we will show that. So trajectory, now we will discuss about the trajectory of the projectile. Which projectile? The oblique projectile. Trajectory means the path of the projectile, trajectory of an oblique projectile. So as I have already shown, but we will prove that whether this is a parabolic or a straight line or any other path or a circular path, we will prove that. Okay. Now here you see the horizontal motion takes place with a constant velocity. So we can say the horizontal motion ux is u cos theta, and that is uniform. So if this is uniform, then the ax is equal to 0. The acceleration along x, because it is uniform, so it is 0. Why? Because it is uniform. It is not changing because the motion is under gravity. Then the vertical component, that is your this gives, so from here, if x is the horizontal distance, if x is the horizontal distance traveled, x is the horizontal distance traveled in time t, then what we can write? That we can write the distance means x is equal to, suppose horizontal distance x is equal to ux into t plus half ax into t square. As for your equation of kinematics, the distance s is equal to uxt plus half ax t square, because we are considering the x component only, so I have considered the x part. So as you see ax is 0, so I can write this x is equal to, what is my ux? U cos theta into t. So t is equal to my x by u cos theta. This is the equation 1. So this is the x distance traveled with the component of velocity u cos theta in time t, right? So this is suppose your equation 1. Okay. Now we go for the vertical motion of the projectile is controlled by the force of gravity. Now we will go for the vertical. So the vertical motion is controlled by the force of gravity. The projectile increases its height. The projectile, when it is thrown, it increases its height. Then it goes to a maximum height. So this is the maximum height. After that, so when it goes to the maximum height, what happens? The gravity pulls the body. When it goes above this height from the surface, the gravity pulls the body. So when the gravity pulls the body, it has some initial motion given. So it has a component u sin theta. This u sin theta component goes on decreasing. Then at the maximum height, this u sin theta becomes 0. Means this vertical velocity becomes 0. So it is no more in this direction, there is no velocity. Okay. So here the final velocity becomes, this vertical velocity becomes 0. When this vertical velocity becomes 0, the acceleration always downward, so this acceleration dominate over this velocity. So this acceleration, the vertically down, that is g, dominates and the body comes back to the surface. And as you know, if it is thrown with a velocity u at this point, then at the same horizontal height, if a body is projected with a velocity u, then it will come back to the ground with the same velocity, but the direction is different. Here it is thrown with a velocity u upward, here the velocity come with the same magnitude, but the direction is different. That is the concept. Suppose here it is the velocity, suppose here, that is suppose v, then at this point, when it comes to this point, then the velocity will be v, but opposite direction. At the same level, the velocity should be same. That is a equation of kinematics. From equation of kinematics already we discussed this part. Okay. Now we will go for the, so from here, let me write here the equation 1 I got, t is equal to x by u cos theta. That is my equation number 1. Let me erase this thing. Now we go for the vertical motion. So in this vertical motion, as I have already told that the projectile increases its height up to a maximum height where its velocity, vertical velocity becomes 0. After this, the projectile reverses its vertical direction and returns to earth. Reverse its vertical direction. Here, after that, it reverses its vertical direction. Means up to here, suppose you consider this is the vertical, but here it is the vertical. Reverse its direction. Then, after reaching the maximum height, after that, then the reverse its direction and returns to earth, striking the ground with the same velocity or same speed u, but the direction is different. Okay, and same as the in that part, if y is the, so here the y component is equal to initial velocity y, uy is equal to u sin theta, and the acceleration ay is always vertically downward. Always in sign convention, the acceleration is with the vertical acceleration is always constant. So uniformly accelerated motion in vertical direction. So that is equal to g. Always we will consider ay is equal to minus g. And if y is the vertical distance covered by the projectile, if y is the vertical distance covered by the projectile, distance covered by the projectile, in the same time t, in the time t, then now if you consider this path is in time t, means y is equal to, we can say, means s is equal to, here s is the, we are discussing about the vertical part, means this part y, this is your x. So y is equal to uy with initial velocity is what? Only y component, uyt plus half ay t square, only the acceleration in y direction. So if you put that, y is equal to, your uy is equal to u sin theta into t plus half ay is equal to minus g into t square, or you can write this is equal to y is equal to u sin theta into t minus half g t square. So let this is equation 2. Let this is your equation number 2. Now you putting this equation 1 in equation 2, because we have got an expression for t. Putting equation 2 in equation 1, let me write it, erase this part. Putting equation 2, we are discussing the trajectory, right? Putting equation 2 in equation 1, sorry, putting equation 1 in equation 2, putting equation 1 in equation 2, what you will get? Y is equal to u sin theta, what is my t? X by u cos theta, u sin theta x by u cos theta minus half g t square x square by u square cos square theta. Okay. So if I make it is more interesting. So this is equal to u get cancelled. So x tan theta sin theta by cos theta, that is tan theta, minus half g by u square cos square theta into x square. So I got the expression for y, clear, by using this equation 1 and 2. Now we will discuss this part. Y is equal to x tan theta minus half g by u square cos square theta x square. So this is a first degree equation in y. First degree means power of y is 1, and a second degree equation in x, there is x square, x power 1 and this is x power 2. So second degree in 2, right? This is the equation of a parabola. This is an equation of a parabola. What is the equation of parabola? Remember, the equation of parabola is y is equal to ax minus bx square. Here a is the tan theta, b is here half g u square cos square. This is general equation of a parabola. Means what? Generally the equations of already you know in mathematics, or you will read that in mathematics. Y is equal to mx plus c. Degree 1 of y, degree 1 of x. So this is an equation of a straight line. Like that, this type of equations are equation of a parabola, where degree of y is 1, degree of x is 2. So this a and b, that gives you an equation of a parabola. So this is the equation of a parabola. So the path or the trajectory means y factor is like this. So you can say the trajectory of a projectile is parabolic, and in this equation it is a parabolic. And remember one thing, the trajectory is a parabolic, and from that trajectory it is if we can say the equation of is a trajectory, and the shape of the curve above x axis, the shape of the curve parabolic curve above x axis is symmetric about a vertical line passing through the highest point. So this is the vertical line passing through the highest point. If this type of equation is there, then it is symmetric, means what is the curve here, the same thing is here. It is symmetric, both sides looks, means the mirror image you can say, both sides are same. So it is symmetric like this. Okay, this type of equation is the equation of a parabola. That means the trajectory of the projectile is a parabola. Okay, from here also in this equation, again another thing that is valid, this equation is valid only if this theta lies between 0 to pi by 2. Only when this theta lies between 0 to pi by 2. This equation is valid only under this condition, because it has a theta which is less than 90. If the projectile is fired at 90, so only this component here, the u will be like this is the u along this direction. If this is the u, vertically u, then what is the horizontal component of this u? This horizontal component is ux is equal to 0, because there is a vector a. What is this component along this direction? This is your component along x is 0, because there is no, because if you resolve that, this is 90. So a cos 90 is equal to this x, that is equal to 0. Already you discussed in the resolution of vectors. Okay. Now we can write this in different forms, and we can make like different way, that we can write this as let me write. So we got this, the trajectory is a parabolic. So let me simplify this thing. I will write like in another form. Let me write y is equal to, I can write x tan theta minus, I can write this as y is equal to x tan theta minus x square divided by 2u square cos square theta by g. Can we write like this? 2u square cos square theta by g. Can we write? Yes. So it means now I will make like this into cos theta. I will write this as one factor like that. So this is cos theta. Okay. So let me take another step. This is 2u square cos square theta into g. So I can write this is equal to x tan theta minus x square divided by 2u square cos theta into sin theta into sin theta. Let the sin theta cancel, the other is cos theta, so this is cos theta divided by g. Can we write like this? Same thing, sin theta cancel, this is cos square theta. Okay, is that clear? So I will write this in different way like that. So this will give me as another factor, that is equal to, can write y is equal to, I can write x tan theta minus x square minus x square tan theta divided by r. R is called as the horizontal range, means what is that maximum distance? This is the horizontal range r. We will discuss this r factor, but I can write like this. For the time being, you remember this r is the range, means horizontal distance, maximum horizontal distance covered when it is projected. Means I will throw a body here, it will not come to here again, it will go to certain height and then it fall back at certain distance apart from me. This is the point of projection, but the body will fall at certain horizontal distance, covered at certain horizontal distance. So this is the range, and this is equal to, we can write this is the range by 2u square, right, x square tan theta by r. Clear? So I can write this is the also a equation of a projectile. Y is equal to ax minus b x square, okay, which is symmetric about the both the axes. Clear? Next we will go for another parameter that is the maximum height. Let me, okay, now come to the maximum height. I have shown this figure again, the projectile motion, projectile with u cos theta and u sin theta. What is this maximum height? The maximum height means, remember the definition, it is the maximum height to which a projectile rises above the horizontal plane of projection. So this is the horizontal plane of projection. Up to what maximum it will go height, that is called as the maximum height. So here I will show that, let the projectile goes to this point and this is the maximum height h. We can show this as a maximum height as a h. And remember one thing, when the body is at the maximum height, what is at every point, it has the, suppose at this point it is a horizontal component and also a vertical component. Similarly here also there is only the horizontal, the vertical component is 0. The vertical component is 0. This motion with velocity u, it changes like that. So here the vertical along y direction, that is your 0, means it has only y component, that is your ux, and this vy, I have dotted in there, vy is equal to, or ui, you can say that ui, the y component here it is 0. Clear? So with this initial velocity u, so I can show this as ux and ui, or similarly final velocity vy, or with any notation you can show that. That means at this maximum height, its vertical component is 0. So it is the also known as vertical range. This is also known as the vertical range. So in order to calculate the maximum height, we have to calculate, then as it is the motion in vertical direction, so we will only consider the vertical parameters. So like the vertical parameters, like here we can say that one is, so at this point, suppose the final velocity is, it is with the velocity u, here it is ux, it is shown as, let me show like this, it is uy, and this is your ux, and here when it reach here, so this is initial, so this is your vx and this is your vy, which is equal to obviously 0, because it is not going above this. From here it falls down, reverse its direction. So final velocity goes on decreasing. This y component goes on decreasing because the acceleration is pulling down. Acceleration is a gravity. So because of that, as it goes height like this, here that final velocity becomes 0. So Vy is equal to 0 with initial Uy, it is given as how much? U sin theta. With velocity Uy is equal to U sin theta. And obviously here we will consider the Ay is equal to minus g. Ay is equal to minus g. And what is the distance travelled? This is h. So I can say this s is equal to h, and it is positive. Why? Because goes up above the height, it goes up, the distance is covered up, above positive, below negative. Use the sign convention, same thing. So according to that one, if I use the equation of kinematics, v square minus u square, only the y factor, is equal to v square minus u square equal to 2as. And what this s along y? That is h. So vy square means 0 minus u sin theta whole square is equal to minus 2g h. Minus 2g h. Okay. So this is equal to, I can write minus u square sin square theta is equal to minus 2g h. This minus minus get cancelled. So what is this height? I have to find the expression for height. H is equal to u square sin square theta divided by 2g. This is very important formula for the maximum height. So we can write this as also, or you can write like this. This can be written as h is equal to, I can write, what is u square sin square theta? Uy, the y component square, uy square by 2g. I can also write this maximum height is because of the y component of the velocity. Clear? Then this is the vertical component of the motion. And for maximum height means if a body is projected, and what will be the maximum height the body can go, at what angle I should project so that it will go to the maximum height. See here, to get this h to max means in this case, to make this h maximum, what I have to do? U square 2g, that is the maximum. When sin square theta is equal to 1, the maximum value of sin square theta is 1. That will give you the maximum, right? So sin square theta is a maximum. What is the maximum value of sin square theta? 1. So theta will be equal to 90 degree. Theta is equal to 90 degree. Means with a velocity u, if I project a body with a velocity u, if I project a body horizontally, this theta is 90. So it will go to the maximum height, that is your h max. But with velocity u, if you project with an angle theta which is less than this 90, it will go less height compared to this height. That is my point. That is the point you have to remember. Means if I throw a body with the same velocity u with 90 degree to the horizontal, and another body with the same velocity u at an angle less than 90. So in that two cases, in which case? In 90 degree case, when theta is 90 degree, it will go to the maximum height. How much? That is equal to u square by 2g. Okay. So for complementary angles of projection, the ratio of maximum height. Now I will find for complementary angle of projection. Complementary angle of projection, what is the ratio of the maximum height? That may be a question like that. So for complementary means what? Complementary means one is a body is projected with an angle theta, another is by an angle 90 minus theta. Means one is at 30 degree, other one is at 60 degree. For complementary angles of projection. Now we put here like this. So for theta projection, h1 is equal to, then I will go for 90 theta. h1 is equal to u square sin square theta divided by 2g. For 90 minus theta, I can write this h2 is equal to u square sin square, in place of theta I will put 90 minus theta by 2g. U square sin square 90 minus theta by 2g. So what this will give me? So sin, so this, if you divide this h1 by h2, u square get cancelled, 2g cancel, so sin square theta divided by sin square 90 minus theta, that is your cos square theta, sin 90 minus theta cos theta, sin square theta by cos square theta. So this will be give you as tan square theta for complementary angle what is the ratio of heights, that may be a problem, maybe a question like us. So these are the different parameters we have discussed for a projectile projected obliquely with some angle to the horizontal. Is that clear? So next class we will go for some other parameters about the range, what is the maximum range, what is the time of flight, that parameters we will discuss in the next class. Go through this video, students, and get a clear idea about this projectile motion. Thank you.